This is Mr. Hanna, and welcome to What the Format. Today we're going to go over graphing quadratics from Vertex form. So this is what Vertex form looks like. Remember one of my last videos we did completing the square to go from standard form to Vertex form. This is why we like Vertex form. It's similar to linear equations. We've got standard form and then you have slope-intercept form. Graphing from slope-intercept form is easier than graphing from standard form, generally speaking. Same thing here, Vertex form. It's easier to graph a quadratic from vertex form. So now you know how to read it. Okay, so if we were talking about transformations, remember a lot of functions, they talk about transformations. Well, this went 3 to the right. Remember, it's opposite of its sign. Then it went 1 down. There's your vertical stretch by 2. Okay, notice there's no negative, so you don't have the x-axis reflection. The vertex is at the opposite of this, 3, -1. The vertex is your turning point for this quadratic. Quadratics are used, so you have one end coming, basically if you look at it from the left, you're coming down and you're going back up. That turning point is your vertex, okay? So this is the vertex right there. Absolute value equations also have a vertex. Now, I also refer to this as the 0 point. This is where you're taking basically 0 squared. Well, how does that work? We'll go over 1, 2, 3. If we plug 3 in for x, what's 3 minus 3? Well, 0. So then you got 0 squared, which is 0. 0 times 2 is 0 minus 1. Okay, so I call that your 0 point because there are a lot of other functions that don't have a vertex because it's they don't have a turning point like the b or the u do. They don't call it a vertex, but it's still a 0 point. It's where you're taking the square root of 0 or 0 cubed or the natural log of 0. Okay, now if you're into logarithms, you know you can't actually take the natural log of 0, but that's your 0 point. Okay, that would actually be your vertical asymptote. So it's still a valuable point to know. Okay, so the 0 point or vertex. Then what you can do is from the vertex, you go over 2 from either side. Okay, now I've learned the pattern. Basically, when you go over 1 from either side of the vertex, you go up or down a. Well, what's a? It's this number right here. Remember, this is your a times x minus h squared plus k. So you go up your a. So we went over 1, up 2, 1, 2. Over 1, up 2. Now, if you wanted to plug values in, just go ahead and do that. What's 4 minus 3? 1. 1 squared is 1 times 2 is 2. 2 minus 1 is 1. So there's your 4, 1. Negative 2, or sorry, not negative 2, positive 2. 2 minus 3 is negative 1, but remember negative 1 squared is also 1. 1 times 2 is 2. 2 minus 1 is 1. So there you go. Those are the 2 points. So those are the 2 ways to do it. You can plug in the values to either side of the vertex and do the math. Okay. Once you plug in 1, they mirror across this axis of symmetry. You'll notice I call it the AOS. That's the axis of symmetry. That's a vertical line. I dash it, x equals 3. This is the line across which the quadratic mirrors. So you notice these are the same on either side, so are these. Okay. So then the other way you can go over 2, well, then you go up 4a. Why? Because 2 squared is 4. Over 2, 2 squared is 4, up 4a. 4 times 2 is 8. So I went up 8 to there, up 8 to there. Again, you can plug in the point 5 minus 3, 2. There's your 2 squared. 4 times 2 is 8, minus 1 is 7. So those are the ways to get the points to graph. You can remember the pattern. You can just plug the numbers in, do your XY table. If you did the XY table, it would look like this. Okay, we have our vertex, which is a 3, -1. We did 2, 1, 4, 5. We came up with 1 there and 7 there just by plugging in the math. And then they mirror like that. Go ahead and practice with it. With linear functions, hopefully you've already had some practice making the XY table where you just pick values of x, plug that value, substitute that number in here, and then just do the math. Remember, at that point, it's forward PEMDAS. Okay, so over here, same idea. This time we went left 2 and up 4. So my vertex is at -2, +4. We have a vertical stretch of 3. Remember, it doesn't matter if it's negative. If the number is greater than 1, it's still a stretch. But now we have the x-axis reflection. That's why you see it going down. The axis symmetry is x equals the -2. If you're having trouble seeing that, just set x plus 2 equal to 0 and solve for x. And what do you get? X equals -2. That is then your x-coordinate of your vertex. It's also your axis of symmetry. -2 plus 2 is 0. 0 squared is 0 times -3 is 0. So 0 plus 4 is 4. That's why the vertex is at -2, 4. The domain on these is all real numbers. There's no number that you can't plug in for x and then square it. The range, however, because the function goes up or down, the turning point, that y-coordinate of the vertex is your range value. So here, since we're going down, where y is less than or equal to 4. Let me get that a little bit bigger. X is less than or equal to 4. When you're going up, you're greater than or equal to. So in this case, greater than or equal to -1. That point is also your minimum or your maximum. If the quadratic goes up, your y-coordinate of your vertex right here, the -1, this is also the y-coordinate of the vertex. Hopefully you can see those. Okay, that's also your minimum, and it's where your range either goes up from there or, like over here, it goes down from here. So my maximum, because now I'm going down, that's the maximum point I hit is 4, and the range is y is less than or equal to 4. Anyway, so what we did here, see, it said over 1, up or down a, so I went over 1, a is 3, so I went down 3. 1, 2, 3, I went over 1, down 3. Now, that's all the points you need, 3, to graph a quadratic. I put the fourth and fifth point over here because we only went up 2. A lot of times you only go up 1, and so it's not really, it's harder to get the shape of the U right with only those 2, especially when they're close to the vertex. And a lot of teachers or places, they want 5 points. But the bigger the A is, you don't really need those. Now, if we did want to go over again, okay, so that was -2, that's -3, to go -4, or probably easier to go 0, because 0 plus 2 is 2, 2 squared is 4, 4 times -3, -12 plus 4 is -8, we'd all be all the way down here at -8, okay? And then we would just mirror that point over the axis of symmetry, which is just a dashed vertical line down to, and we write it as x equals. Now, please be careful with the axis of symmetry, I always need x equals, because it is a vertical line, it's a linear equation at that point. But that's how you graph quadratics, okay? And you could also list the transformation way. Again, 2 to the left, 4 up, vertically stretched by 3, and then that is an x-axis reflection. Those are your 4 main transformations. Now there are times they put numbers or negatives in front of the x, but that's something for another time. I don't see that really taught right anymore. They call those a horizontal dilation, horizontal stretch or shrink, and then it would be a y-axis reflection. But this transformation changes based off what the function is. And I don't see them teach that very often. So usually when there's a transformation there, I don't try to, I go with what the teacher says. So if your teacher says do this, just follow that. And then to get the points, I actually just plug numbers in and just get my XY table, because it's just safer that way. Less chance of making a mistake. Anyway, so, but most of the quadratics that you're going to see, this is what they look like in vertex form. So that's why we go from standard form to vertex form, graphing them like this. These are all the parts. Hopefully that's helped. Thank you for watching What the Format. This is Mr. Hanna. Happy mathing.